Hey guys, this topic's video has to do with a concert and asking a question of whether um, the noise level is where it needs to be based off of a concert. And this girl, Melissa, who's checking it out. So, what it says here is the noise level at a music concert must be no more than 80 decibels at the edge of the property on which the concert is held. So Melissa uses a decibel meter to test whether the noise level at the edge of the property is no more than 80. So we know that when she stands 10 feet away from the speakers, the noise level is at 100 decibels. The edge of the property is 70 feet away from the speakers, and every time the distance between the speakers and Melissa doubles, the noise level decreases by 6 decibels. So Raphael claims that the noise level at the edge of the property is no more than 80 decibels since the edge of the property is over 4 times the distance from where Melissa is standing. Explain whether Raphael is or is not correct. Okay, so it took me a while to kind of wrap my brain around this problem here. But what I think we should do is let's use the scatter plot option. So let's put in some relationships that we know based off of distance and decibel time, or decibel level, and then plot those points on GeoGebra, and then just out of curiosity, see what kind of function would model this this relationship the best that we can. Okay, so what I thought about doing was we really have 4 data points based off of the information we have here. So what happens is when her distance from the speaker doubles, so she's standing at 10 feet, the decibel is 100 feet. So when she doubles that distance, so we get to 20 feet, then the noise level should go down 6 decibels. So we should get to 94 decibels at 20 feet. And then when that distance doubles, so at 40 feet, then we're going to go down 6 more. So that'll be kind of the pattern. Let's take a look at what's going on here. So open up a GeoGebra, go to View and view your spreadsheet. And since we are going to plot the points, you may want your grid lines and your axes showing here. So first of all, let's put our relationships that we have here. Let's use this first column here for distance from speaker. And if you want your students to understand axes and what they are, they can right-click an axis on the graphics window, or anywhere in the graphics really. Go to your graphics options, and then I believe for x-axis we can actually label it, and we can call this distance from speaker. And when I hit enter, notice down on the bottom corner here we got what that axis is representing. So that's pretty nice. Y-axis will do the same thing. We'll call this decibel level. Okay, we may even want to put our maximum decibel level at the edge of the property of 80 decibels in there, but we can do that later. Okay, so in our table here, since the A column will be our distance from the speaker, we know that we can be 10 feet away. There's going to be 100 for decibel level. Then let's double 20, and then let's double that, which is 40. Double that, which is 80. So the edge of the property was only 70 feet from the speakers, and so when we double here, we'll get to just outside the property, 10 feet outside the property. Now it says every time that Melissa's distance doubled, the decibel level goes down 6. So from 100, we are now at 94 decibels. If we take away 6 more from 94, I believe we're at 88. And then if we take away 6 more from here, we're at 82. So really right now we have the answer to the problem. At 80 feet away from the speakers, the decibel level is 82. So since the property line is 70 feet away, it's going to be higher than 82, the decibel level. So Raphael, I think, is wrong, and this concert is going to get a noise complaint. Okay, so let's see what this relationship actually looks like, though. So I'm going to go ahead and click and highlight all my data. I'm going to go to this third toolbox here, which by default is the Create List tool, but we don't want to create a list. We want to create a list of points. So I'm going to click on that. Here's our relationship that we want to graph, and that looks good to me. So I'm going to hit Create. Now, if yours is like mine, nothing happened. But if you think about our x values, our distance from the speaker, we're going from 10 units to 80 units. So we're only looking at 10 to like Here's 10. So we need a lot more here. And then also, our outputs, our decibel levels, have to go from 100 to 82, and I'm only going up by 10. So again, no matter what tool you have selected, if you hold control on your keyboard, and I'm going to hover over the x-axis. I have control held down on my keyboard, and if I hover over the x-axis, I can click and drag my x-axis to change the scale. And I want to go all the way out to my 80 feet. So there's 80 feet there. Alright, now on the y-axis, do the same thing. I'm going to hold control again, and I'm going to drag the y-axis to the origin so that I can see our 100 and our other points. So now all of a sudden, here's our points. We just had to rescale our grid here. You could do that same thing if you just get your Move Graphics View tool. They'll do the same thing. So we can see here that this isn't linear, which is pretty cool. What kind of model actually fits that? So let's do a regression on these 4 points, and let's see what model fits this the best. So I'm going to select my data again. The second toolbox here, where by default is the 1 variable analysis, we want to actually go to 2 variable regression analysis. So we're going to click on that tool. It tells us here's our A column and our B column, and that looks like what we want. So now here's our points, and my regression was set by default to a linear. So here's the model that best fits that data if we were to choose a linear model. And that doesn't seem to fit very well. And students that actually think it's a linear model will say that Raphael's claim is correct, that if he hits that 70, we're going to be at where we want to be. But that's not correct. So in your regression model, we have all sorts of options you can make. You can just see, like, for example, if we go a log regression, that's actually pretty close, right? That seems like it could be a log regression. We can try sine. Nothing pops up for sine. A growth. This is what it comes up with, a growth model. Exponential model. Doesn't look very good either. Here's a power model. Ooh, that looks pretty good. That looks like our log. 124.84 times x raised to the negative 0.1. Which you may or may not. Your students may not even know what this equation means, but this is the whole idea of input and output, right? So we could check this. If we're 20 feet away, our decibel level is 93, which we 93.8, which we said 94. So that's pretty close. So at 70 feet, based off this model, our decibel level is going to be 83.23 based off this model. So that would not be under 80. But pretty cool tool how you can pick a model to fit, and then you can actually do some cool little evaluations right here. Now, if you wanted your graph to actually go on your graphics view in here, then all you need to do is click on this little option that has the arrow going out. So we're going to send this out and copy it to our graphics view. And now when we do that, it sets our graph. It did change our scale around a little bit. So if we wanted to see everything, I'm just going to rescale my y-axis here. But there is our model that fits that pretty well. So at the speaker, you could even ask, what's the decibel level at the speaker? And as you go, our model will never actually get to the speaker, but it's pretty loud. So anyways, just a quick example of how you can take a problem, how putting the relationship in a table, it's pretty easy to see that Raphael's claim is incorrect, but then extending that thought into what model, this isn't linear, this isn't quadratic necessarily, so what would be a good model to fit? GeoGebra's regression capabilities make it relatively simple to get our model, and then we can just evaluate. Thank you, guys.